Hi everyone, today we are going to solve a common kinematic problem. Okay guys, first of all we need to read the question carefully to understand what it asks. Okay, let's start. At the base of a vertical cliff, a model rocket starting from rest is launched upwards at t equals 0 with a time varying acceleration given by this function where a and b are positive constant. Also, at t equals 0, a small stone is released from rest from the top of the cliff at a height a directly above the rocket. This height, h, is higher than the maximum height reached by the rocket. The stone hits the rocket at the instant when the rocket reaches its maximum height. The gravitational acceleration of magnitude g is downward. You may neglect air resistance. Determine an expression for the initial height h from which the stone was dropped in terms of constant a, b, and g. Okay, guys, the most important sentence in here, this sentence. This height h is higher than the maximum height reached by the rocket. It says that the rocket moves to some location and it will stop there. Then the stone and rocket will hit each other when the rocket reach the highest location. It says that. Okay then, if the acceleration was the constant, we could write the location function like this: x of t equal x0 plus v0 minus times t plus 1 divided by 2 times a times t squared. But acceleration is not constant. That's why we should define the location function like this. We know that a equal dv divided by dt, and to isolate the dv, we can move the dt to the left side, and a times dt equal dv. Then we integrate the both sides. We get this. We have a function for here, and a times t minus bt squared divided by 2 and some constant value, right? There is no parentheses. No need. And there is a v of t. Then guys, we have a constant value. You should ask this question: what is the constant value? We should find this because in physics we don't like the constant values. Guys, you can see that if we put the 0 for t, like I'm saying, when t equals 0, our velocity is 0. How do we know this? When t equals 0, the rocket is rest from here. Then v equals 0. So d is 0, and 0 plus c1 constant value equals 0 when c1 equals 0. This is not important. Then guys, we should keep going to find the location function. We write this velocity of t equal dx divided by dt, and to isolate the dx, we move to the dt to our left side. Then v dt equal dx, then integrate the both side, and we get this like at squared divided by 2 minus bt cubed divided by 6 and some constant value equal xt. So guys, again we can put the 0 for the t and find the constant value. As you see, the constant value again is 0, then we don't need to use the constant value. So we find the location function for the rocket, but we didn't find the location function for the stone. How do we find this? As you can see guys, the acceleration for the stone is constant and it's equal to g, gravitational acceleration. So we can write the location function like that way. x0 equal h and plus minus g, this is important, minus g 1 divided by 2 and t square. We don't have an initial velocity, that's why we didn't write anything. This is our location function for the stone. So guys, we should find the t, but which t should we find? We should find the t which they hit each other. Okay, you may think this. How do we find this t? Guys, imagine that this rocket is moving to the upside and losing his acceleration by the time. So for a while his acceleration will be 0, right? And his velocity will be 0 too for a while. If we find the velocity when it is 0, we can find the time when they hit each other. So we have a v function a t minus bt square divided by 2 should be equal 0. We should find the root for the equation. So the first root is 0, but careful guys, if you write the 0 for the t, you will get these option. When the rocket is resting, rocket's velocity of rocket is 0. We should find another option for it. So that's why we can simplify these, and a minus bt divided by 2 equals 0. We can move this quantity to the right side. A equal bt divided by 2, and t equal to a divided by b. Okay, we find the b. Then the location function for both of them should be equal when t equal to a divided by b. Guys, let's call it 2a divided by b u. Okay? It's make easier to solve this problem. We have these equation, these function for a rocket, and these function for stone. So write this: a t squared divided by 2 minus bt cubed divided by 6 equal h plus, I think we don't need to write plus, minus g 1 divided by 2 t squared. And we find the t as a u. We can write the u for it: a u squared divided by 2 minus b u cubed divided by 6 equal h minus g 1 divided by 2 u squared. So we should isolate the h and move these quantities to the left side. A u squared divided by 2 minus b cubed divided by 6 and plus g 1 divided by 2, and then u squared. We should times these equation, like not like that, like that, and what do we get? U squared 6 bu cubed 6 3 g 1 divided by 6 u squared. Okay, like we find this, but it's too complicated, guys. We should write the u for this use and find the quantities, blah blah blah. It's so, it will take so long time. That's why we don't need to solve this actually, but we find this. But we can write like this: a 2a divided by b square 6. I think we should do this: b 2a b cube plus 3g 2a divided by b and then square 6. This is h. I know, guys, it looks very bad, but what we can do? What should we do? This is our question. Okay, guys, then if you didn't understand something or part of this question, you can ask me on the comments. And sorry if I did the mistake when I speak English. It's not my native language. And if you are listening for 15 minutes, I really appreciate it. And please like it and subscribe it. See you guys.